Scart. Scart, also known as parietal or paratelevision, especially in France. 21-pin Euroscart in marketing by Sharp in Asia, Eurocompter in Spain, EuroAvor Ixt, or EIA Multiport in the United States as an EIA interface, is a French-originated standard and associated 21-pin connector for connecting audio-visual AV. The name Scart comes from Syndicat des Constructeurs d'Appareils Radio-Récepteurs et Téléviseurs, Radio and Television Receiver Manufacturers Association, the French organization that created the connector in the mid-1970s. The related European standard EN 50049 has then been refined and published in 1978 by CENELEC, calling it paratelevision, but it is commonly called by the abbreviation parietal in French. The signals carried by Scart include both composite and Rgb with composite synchronization video, stereo audio input/output, and digital signaling. The standard was extended at the end of the 1980s to support the newest video signals. A TV can be woken from standby mode and automatically switched to the appropriate AV channel when the Scart-attached device is switched on. Scart was also used for high-definition signals such as 720 type, 1080, 1080 type with YPbPr connection by some manufacturers, but this usage is scarce due to the advent of HDMI. In Europe, Scart was the most common method of connecting AV equipment and was a standard connector for such devices. It was far less common elsewhere. The official standard for Scart is CENELEC document number EN 50049-1. Scart is sometimes referred to as the IEC 933-1 standard. History. Before Scart was introduced, TV did not offer a standardized way of inputting signals other than RF antenna connectors, and these differed between countries. Assuming other connectors even existed, devices made by various companies could have different and incompatible standards. For example, a domestic VCR could output a composite video signal through a German-originated DIN-style connector. The Scart connector first appeared on TV in 1977. It became compulsory on new TV sold in France from January 1980 and since 1989/1990 in Eastern Europe, such as Poland. The actual French legal decree was adopted on 7 February 1980 and revoked on 3 July 2015. The standard was subject to several amendments and at least 2 major revisions approved by CENELEC on 13 November 1988 EN 50049-1, 1989, and 1 July 1997 EN 50049-1, 1997. Features. The Scart system was intended to simplify connecting AV equipment, including TV, VCRs, DVD players, and games consoles. To achieve this, it gathered all of the analog signal connections into a single cable with a unique connector, which normally made incorrect connections nearly impossible. The signals carried by Scart include both composite and Rgb with composite synchronization video, stereo audio input/output, and digital signaling. The standard was extended at the end of the 1980s to support the newest video signals. A TV can be awakened from standby mode, and it can automatically switch to appropriate AV channel when the device attached to it through a Scart connector is turned on. Scart connection was also used for high-definition signals like 720 type, 1080, 1080 type with YPbPr connection by some manufacturers, but to the present day this connection is very scarce due to the advent of HDMI. Daisy chaining. Scart is bidirectional regarding standard composite video and analog audio. A TV will typically send the antenna audio and video signals to the Scart sockets all the time and watch for return signals to display and reproduce them. This allows transparent set-top boxes without any tuner, which just hook and pre-process the TV signals. This feature is used for analog pay TV like Canal Plus and was used for decoding teletext. A VCR will often have 2 Scart sockets to connect it to the TV up, primary or 1, and for video input from a set-top box or other device down, secondary or 2. When idle or powered off, VCR will usually forward the signals from the TV to the set-top decoder and send the processed result back to the TV. When a scrambled show is recorded, the VCR will drive the set-top box from its own tuner and send the unscrambled signals to the TV for viewing or simple recording control. Alternatively, the VCR could use the signals from the TV, in which case it would be inadvisable to change channels on the TV during the recording. The down socket can also be used to connect other devices, such as DVD players or game consoles. As long as all devices have at least one up and down socket, this allows for connecting a virtually unlimited number of devices to a single Scart socket on the TV. While audio and video signals can travel both up to the TV and down to devices farther away from the TV, this is not true for RGB and non-standard YPbPr signals, which can only travel towards the TV. Up and down are conventional. Logically, the TV is the last device of the up chain path stream and the first device in the down chain path. Physically, the TV is under the device which sits on its top, hence the name set-top box for the device. Moreover, some sockets' relative position may enforce the belief that the TV is physically the last in the down direction. Logically, the TV is on top and ends the up chain path, translating the electrical info into an image and sound. From the same logical point of view, the info stream, wherever it originates, may need processing such as decrypting, decoding, descrambling, or adding captioning/subtitles. In this case, the info stream is sent logically down to dedicated function devices. From the last processing device, the info stream is sent logically up to the TV through all the chain path. Another case is when the info stream is sent down and not expected to be sent back up, for example, when sent to a recorder. Closing a loop on either the up or down chain path may not have useful effects and may create instability. Direct connections. As audio and composite video use the same pins on up and down connectors and require a cross-linked cable, it is also possible to connect two devices directly to each other without paying attention to the type of the socket. However, this no longer works when S-video signals are used. As straight links RGB red and blue up were repurposed to carry chrominance information, the S-video pinouts are different for up and down Scart connectors. Further, they are often not fully implemented. Paying attention to the type of socket is essential when handling component RGB/YPbPr/S-video. Damage can be caused to devices incorrectly connected as follows. Connecting Scart 1-up from one device to Scart 1-up of another device when both Scarts are configured for RGB/YPbPr/S-video up. Pins 7, 11, and 15 are outputs. Connecting Scart 2 down from one device to Scart 2 down of another device when both Scarts are configured for S-video down. Pin 7 is an output. Connecting Scart 1-up from a device configured RGB/YPbPr to Scart 2 down of another device configured with S-video down. Pin 7 is an output. Damaging pins 7, 11, or 15 may result in yellow, purple, or blue/green images due to the missing blue, green, or red components respectively. When using S-video, damaging pin 7 or 15 may result in black-white images due to the missing chroma component down and up respectively. Similarly, damaging pins 7 and 15 PB and PR while leaving pin 11Y undamaged may result in black-white images when using YPbPr. Damaging more than one of these pins may result in combined effects. Rgb overlays. Scart enables a device to command the TV to very quickly switch between signals in order to create overlays in the image. In order to implement captioning or subtitles, a Scart set-top box does not have to process and send back a complete new video signal, which would require full decoding and re-encoding of the color information, a signal-degrading and costly process, especially given the presence of different standards in Europe. The box can instead ask the TV to stop displaying the normal signal and display a signal it generates internally for selected image areas, with pixel-level granularity. This can also be driven by the use of a transparent color in a teletext page. Device control. Scart allows a connected device to bring it in and out of standby mode or to switch it to the AV channel. A VCR or other playback device will optimally power on when a cassette is inserted, power on the TV, or switch it to video mode, and then start playing immediately if the cassette's write protection tab is absent. When turned off, the VCR will ask the TV to power off, which it will do if it had been powered on by the VCR request and if it remained in video mode. Only some TV will do this. Most only implement automatic switching to and from the Scart input. The same signal can be used by a satellite receiver or set-top box to signal a VCR that it is supposed to start and stop recording pin 8 recording. This configuration usually requires that the VCR be farther from the TV than the source, so the signal usually travels down. Scart also supports automatic widescreen switching. This is an extension of the functionality of a pin which previously only indicated to the TV that an external signal should be displayed. Ideally, a widescreen source should offer 3 operating modes in order to deal with widescreen signals. Widescreen for TV that are widescreen or capable of otherwise dealing with widescreen images. Letterbox, which adds blank space, usually black at the top and bottom of the image to give a 4:3 aspect ratio. Pan and scan, which crops the image to achieve a 4:3 aspect ratio. Only the center portion is displayed with the sides truncated as if zoomed into. In the first case, the widescreen pin allows to indicate the current signal format, which allows widescreen TV to adjust the image width and widescreen capable standard TV to compress the scan lines of the 576 image vertically. In the second case, the widescreen Scart signal is never active and the signal source performs the adaptations itself, so some sources assume that the TV is always capable of widescreen functionality and, hence, never perform the adaptations. Some sources will not even issue the widescreen signal or maintain it at the same level all the time. Other sources might offer the option of truncating the sides, but not of letterboxing, which requires significantly more processing. Notably, the circuitry of the early widescreen MAC standard decoders, e.g., the VCIPS, could not letterbox. The limitations apply mostly to satellite TV, while DVD players can always at least letterbox and often zoom. Design. Cables. The cables for connecting equipment together have a male plug at each end. Some of the wires, such as ground, data, switching, and RGB, connect to the identical pin number at each end. Others, such as audio and video, are swapped so that an output signal at one end of the cable connects to an input signal at the other end. The complete list of wires that are swapped are pins 1 and 2, pins 3 and 6, pins 17 and 18, pins 19 and 20. The original Scart specification provided for different cable cord set types denoted by a key color, but color coding is rarely used and cables often use different, non-standard configurations. Maximum Scart cable length is estimated to be about 10 to 15 meters without amplification. Due to the relatively high signal voltages used in Scart, hot plugging, connecting, or disconnecting devices while they are on is not recommended. Although there is no risk of personal injury, there is the possibility of damaging electronics within the devices if the connector is inserted improperly. Also, since many TV are class Roman II double insulated rather than earthed, the large exposed shield on the Scart connector will be held at approximately half mains voltage if it is plugged into a powered TV with the other end unplugged. If the cable is then plugged into an earthed device with a metal case, inadvertent contact with the Scart cable shield while the earthed device is touched with the other hand can cause a painful electric shock. For this reason, the device end of the cable should always be plugged in first and the TV end plugged in last. Quality differences exist in Scart cables. While a proper Scart cable uses miniature coaxial cables for the video signals, cheap Scart cables often use plain wires for all signals, resulting in a loss of image quality and greatly reducing the maximum cable length. A common problem on a cheap Scart cable is that a TV outputs a composite video signal from its internal tuner, and this is induced or crosstalked onto an incoming video signal due to inadequate or non-existence. To non-destructively verify if a Scart cable uses coaxial cables, unscrew the strain relief at the Scart connector and fold open the plastic shell. Using higher quality cables, such as those with ribbon cords that have properly shielded coaxial cables inside, might help in reducing a ghosting effect, but it does not always eliminate it due to various factors. A more permanent method is to remove pin 19 video out from the Scart plug that is put into the TV, preventing a signal from being broadcast by the TV into the cable, so it cannot crosstalk with the incoming signal. Blanking and switching. Two pins provide switching signals. Pin 8, the switch signal pin, carries a DC voltage from the source that indicates the type of video present. 0V2V means no signal or internal bypass. 4.5V7V nominal 6V means a widescreen 16:9 signal. 9.5V12V nominal 12V means a normal 4:3 signal. Pin 16, the blanking signal pin, carries a signal from the source that indicates that the signal is either RGB or composite. 0V0.4V means composite. 1V3V nominal 1V means RGB only. The original specification defined pin 16 as a high frequency up to 3 MHz signal that blanked the composite video. The RGB inputs were always active and the signal punches holes in the composite video. This could be used to overlay subtitles from an external teletext decoder. 0V0.4V means composite with a transparent RGB overlay. 1V3V nominal 1V RGB only. There is no switching signal to indicate S-video. Some TV can auto-detect the presence of the S-video signal, but more commonly the S-video input needs to be manually selected. The same for the rare component YPbPr, which is in many cases implemented over a composite or RGB Scart. Non-standard extensions. The use of the data pins was not standardized in the original Scart specification, resulting in the use of several different protocols, both proprietary protocols and semi-proprietary protocols based on standards, such as D2B, 2B. Some of the most creative usages appeared in analog satellite receivers. The function of decoding hybrid, time-compressed analog digital MAC transmissions into RGB and analog audio was akin. The D2B pins 10 and 12 were used for communicating with satellite dish positioners and for driving magnetic polarizers, before these became incorporated into LNB. The daisy chaining features were used to connect both a pay TV decoder and a dish positioner/polarizer to a single decoder socket on the receiver. CENELEC EN50157-1 introduced AV Link as a standardized protocol to carry advanced control information between devices. It is a single-wire serial data bus and allows carrying remote control information and to negotiate analog signal types, e.g. RGB. AV Link is also known as Next View Link or trade names such as Smart Link, Q Link or Easy Link. It appears as the consumer electronics control channel in HDMI. The data pins 10, 12, 14 were used by some manufacturers for Dolby Pro logic. However, this protocol was rarely used as it was limited only to a certain manufacturer, and the connections were different from a manufacturer to another, and in some cases it was only commanded by the pin 8. In this case, it was unusable with RCA to Scart adapters. Also, if a compatible TV with such connection and a compatible DVD with such connection, but from different manufacturers were interconnected, the surround might not work, and only the stereo sound from the DVD player was available to the TV, because some manufacturers did not use a SPDIF, but an own protocol. Also, this connection might be also lost if the connection of the DVD with the TV was made indirectly through a VCR in daisy chaining mode. For example, however, some VCR allowed the pass-through of these signals. Some DVD player manufacturers on some models offered SPDIF only on Scart and an adapter in order to extract the digital audio signal to send it to a home cinema. To the present day, this connection remains rare, as HDMI S/PDIF and Toslink can provide multi-channel audio. Also, some TV sets with surround built-in may have an optical or S/PDIF input beside output. Scart connection was also used, in limited cases, as a high-definition connection by using an YPbPr connection over Scart by some television and audio-video equipment, set-top boxes, DVD players, Blu-ray players, etc. manufacturers. By using an YPbPr connection, Scart could be used for high-definition signals like 720, 1080, 1080. Some manufacturers were using as Y the video composite connection, while others were using the green connection as Y. With the advent of HDMI, and because the connection was not standardized as was S-video and limited only to a certain manufacturer, devices supporting high-definition channels over Scart with YPbPr connection became scarce, if not extinct. In many cases, it was implemented over a Rgb Scart or CVBS Scart, and the YPbPr mode of Scart was manually switched. YPbPr became used as an independent connection, and Scart was left only for standard definition content. Implementations. Nearly all modern DVD players and set-top boxes with Scart sockets can output Rgb signal, which offers superior picture quality to composite signal. However, many devices do not have Rgb output turned on by default, instead defaulting to composite video. Rgb often has to be set up manually in the menu or via switches on the back of the device. The Nintendo GameCube, Wii, Neo Geo, Dreamcast, PlayStation, PlayStation 2, PlayStation 3, Xbox, and Xbox 360 can output Rgb, component video, S-video, or composite video. These consoles come with the standard composite video connector, but the manufacturers and third parties sell connectors for component video hookup and for Rgb Scart hookup. Where the Nintendo GameCube and Xbox automatically switch to the proper mode, the PlayStation 2 must be told via a selection in the system menu whether it is to use YPbPr or Rgb video. Rgb is only available on PL region GameCube and Wii consoles, while S-video is only available on NTSC consoles. Some versions of legacy consoles, such as Sega's Master System, Mega Drive/Genesis, and Nintendo's SNES are capable of outputting Rgb signals, and many older home computers Amstrad CPC, later ZX Spectrum models MSX, Commodore Amiga, Atari ST, BBC Micro, and Acorn Archimedes. Standard resolution arcade monitors use Rgb signals with a composite sync, which is Scart compatible. Besides simple connection of external devices to Scart TV, Rgb Scart is used in the retro gaming scene, even including in North America, for connecting vintage games consoles, including ones internally modified for Rgb or 60HC Rgb, where necessary to. The Rgb Scart inputs of upscalers/analog to digital converters. These output over HDMI at higher than original resolution to modern TV/monitors/projectors/capture cards, or via further conversion HDMI to VGA digital to analog CRT PC monitors. Rgb Scart to Rgb BNC adapters and into Rgb CRT professional video monitors. Rgb Scart to S-video converters for achieving the best video quality on a combination of a TV/monitor with S-video as its best input, but with a console that cannot output S-video, but can output Rgb as its best output. Japanese Rgb 21-pin connector. There is also a Japanese version of the Scart connector, which is referred to as the Japanese Rgb-21 connector, IHTTC-3, or simply JP-21. This version of Scart uses similar signals in the same connector, but it has a different pinout. In Japan and Korea, it is commonly called Rgb-21, while it is more generally called JP-21 in the English-speaking world. JP-21 was standardized in January 1983 with the norm TTC-3 published by iEdge, which was superseded in March 1993 by the norm CPR-1201 to include S-video. CPR-1201 was withdrawn in March 2003 to be replaced by the equivalent norm CPR-1205, representing Japan's transition from analog to digital, and thus antiquating analog connectors. It was adopted in Japan for the connector's ability to support RGB output format, no compression nor deterioration of original video signals, but, contrary to Scart in Europe, it never saw widespread use on the consumer market. When using RGB video, the red channel uses the same pins in both standards, so red video with no audio is indicative of mismatching JP-21 Scart with Euro Scart. Notes: audio input 0.40 mvrms, 47 k ohms. Audio output 0.40 mvrms, 10 k ohms. CVBS composite video in and out 1 VPP 75 ohms. Sync negative. Input switches RGB to half brightness. For video overlay L 0.4V H1V 75 ohms. Wise input RGB and /out ground for output. 1V plus for input preferred. All RGB lines 0.7 VPP 75 ohms. Newer standards. As it was designed to carry analog standard definition content, the use of Scart has declined with the introduction of new digital standards such as HDMI and DisplayPort, which can carry high-definition content and multi-channel audio, though it remains commonly used. HDMI CC is derived from Scart's AV link. However, Scart connection can also support higher definition signals like 400 ATEP, 720 type, 1080 10A type, if the Scart connection of a device is designed to support YPbPr connection, but this configuration is rare. The same for multi-channel audio, but even this configuration remains rare as it is not standardized.